Hi, everyone. Welcome to Keep Learning with KSPS. My name is Amber Smith, and I'm a fourth grade teacher here in Spokane at Finch Elementary. And this lesson is for fourth grade, but anyone is welcome to join. Today, we're going to be talking about how do you change a mixed number into an improper fraction. So you're going to need paper, pencil, and your fabulous brain, and we'll get started.
All right, before we get started on the lesson today, let's do a little warm-up with a couple of fraction problems. And we're going to work on adding some mixed numbers. So I have 10.5 plus 8 and 1/4. So we have to think about a couple things with these problems. One of them is we need to combine the fraction pieces, and the other piece to that is we need to combine the whole numbers. So when we're adding mixed numbers like this together, what I like to do is to think about them kind of separately. So thinking about the whole numbers and then thinking about the fraction pieces as another unit. So like doing this, 10 plus 8 as one part of it, plus a half plus a fourth, because then I can combine these and combine these. So let's start with adding the whole units. So 10 plus 8, can you do that in your head real quick? You should get 18. So we have 18 whole units. And then 1/2 plus 1/4. So we need to think of an equivalent fraction here. So here's 1/2. And then here's 1/4. Can you think about how many fourths are in a half? You could actually split the model. Let me use a different color just to show that a little bit better. And you could see that 1/2 is the same as 2/4. So this would end up being 3/4 because if I add those together. So the answer to this one is 18 and 3/4. All right, let's look at another one. And let's see how we do with that. So let's try this time 10 and 1/4 plus 9 and a half. So again, let's think about adding those whole numbers together and then combining the fractions. And what do you get? So 10 plus 9 is 19. And then we already did one very similar to that just right up here. So maybe we already know that's 3/4. So it should have a combined answer of 19 and 3/4. Now you can use these same strategies for subtraction with mixed numbers too. So if you had a problem such as 10.5 minus 8 and 1/4, well, let's subtract the 10 and the 8. So 10 take away 8, I get 2. And then 1/2 take away 1/4, what would that be? Think about how many fourths are in a half. That's like going 2/4 minus 1/4, right? So I'd get 2/4 minus 1/4 is 1/4. So that's just a quick little run through working with mixed numbers in addition and subtraction. So you might want to try to get the whole numbers together and the fractions together and then work from there. You do have to do some different things with borrowing. So when a number is larger, like if we had 5 and 1/2 minus 2 and 3/4, we would have to do some different things, like get that into an improper fraction. But we're not going to go for that today, but maybe that's a problem you could think about. How could you solve that? So maybe sketch that one down on your paper and think about, is there a way that you can solve that? Because I bet we'll come back to that another day. All right. Our lesson for today, though, is how to change a mixed number into an improper fraction. So a few pieces of vocabulary you need to remember are numerator is that top number of the fraction, and denominator is the bottom number. Denominator and numerator. Numerator top, denominator bottom. Fraction is the whole unit itself. So it is a part of a whole number. An improper fraction is when you have a numerator that is larger than a denominator. And a mixed number is when you have a whole number and a fraction with it. So remember those vocab terms as we're talking today. But today we're going to look at 4 problems. We're going to talk about how do you turn it into an improper fraction, because sometimes you have to do that when you have to borrow in working with fractional pieces. So it's good to know how to turn it into a mixed number and into an improper fraction, because we have to look at them for different kinds of things. So we're going to look at this first one, and I'm going to show you the first way, which is a picture model. How do you get this into an improper fraction? So your first step is to think about the denominator. And the denominator, 6, is going to tell us how many pieces are in a whole. So this denominator says that we were broken up into 6, and we need 2 whole units and 1/6 more. So if I were going to fill out 2 whole units, I would have to fill in this whole piece. So that's 1 whole unit. But I need 2 whole units because my fraction is 2 and 1/6. So I'm going to do another whole unit and shade everything in. So this is 1 whole unit and then another whole unit, so the second whole unit. So let's look at this and let's think about how many 6 is that? If I have, in this one, all of them shaded in, I have 6, 6. If I have all these shaded in, I also have 6, 6. I have to also think about this piece right here. I have 1 more 6 that I have to think about. Because we're talking about this much. So 1 whole, 2 wholes, and then 1/6. So to figure out how to turn this into, go from a mixed number into an improper fraction, I can draw a picture model, and then I can figure out how many fractional pieces did I shade in and add those up. So if I have 1 whole, that's 6, 6. If I have another whole, that's another 6, 6. So that accounts for my 2 whole units. That's right here. And then I have 1/6 more. So quite a few steps to do if you're using a picture model to kind of see what's happening. Then I add my numerators together. My denominator does not change. I don't add those up on the bottom because we're talking, it's like a label. We're talking about units that are cut into 6. But I am going to add the tops together because I want to know how many 6s I have. So if I have 6 plus 6, that's 12, plus 1 more is 13. So 2 and 1/6 is equivalent to 13/6. All right, quite a few steps, right? Let's try it with 1 more, and then I'm going to show you another method where you don't have to draw a picture model. So let's look at it with 1 more picture model. So this number we have 3 and 1/4. So let's talk about what do we need to draw. So how many pieces is our whole unit broken up into? I'm looking again at the denominator, and it's going to tell me I have to break up my units into fourths. So I have 1 whole unit broken up into fourths. Now I have 3 whole units at least that I need to draw, because I have 3 whole. It's like, think about it like candy bars. I have 3 whole candy bars and 1/4 of a candy bar. So I'm going to draw 3 whole candy bars. And then it also said, hey, you've got another piece, a 4th in there. All right, so let's shade these in to help us understand this. So I've got, here's 1 whole candy bar. Shade everything in here. I have 2 whole candy bars. Shade in this one. Now I have 3, and then I have 1/4 because we're talking about this fraction that's with it. So 1/4. So now what I have to do is I have to kind of count those up. So let's count up how many fourths we have that we shaded in all together. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. You can think about it with an equation as well, like we did back on the other problem. So the equation, like I'm talking about this, we can take this and say, well, this one whole, that's 4/4. The second one, that's another 4/4. So I've got 4 pieces shaded in. My third one, that's another 4/4. And my last one here, that was the 1/4. So my denominator does not change, but then I just add those top numbers together. So 4 plus 4 is 8, plus another 4 is 12, plus one more is 13. And see how we counted that 13 all together? So that's using a picture model and breaking it apart into fractional units to get it together. There is one other method that's a little bit quicker, but you have to really follow the steps carefully. So on the next two problems, you could use the picture model to solve. They are larger numbers, so they take a little bit more time if you're going to use a picture model. However, there is one other trick. So I'm going to kind of show you picture model and the trick on this one. So we've got fifths that we're talking about because there's 5 and 4/5. That denominator is fifths. And I know I have 5 whole units because that whole number of 5. So I'm going to draw 5 whole units, breaking them up into fifths. But I know I have some more because we're talking about this 4/5 right here. So I need to draw another bar. And there's 4 in there. So let's think about this. I've got 5 whole bars, and I'm just counting out the fifths. Notice how it's counting by 5s because we're talking about fifths. 5, 10, 15. It takes a while to do one like this, doing the picture model. And then I have 4 in here that I'm filling in. If I'm writing that equation, remember it would look like 5/5 plus 5/5 plus 5/5 plus 5/5, a lot of 5/5. 5/5 because we got 1, 2, 3, 4, 5, plus the 4/5. Wow, that's a lot to put together. So I've got 5, 10, 15, 20, 25, and then 25 plus 4, 29 fifths. That matches up with what I said I would have shaded in. Okay, but here's another method. Here's a method that a lot of people do is they get a little more advanced. So I'm going to erase this and fix it real quick. And here's the trick. What you do is you take the denominator and you multiply it by the whole number. So you take the denominator, multiply it by the whole number, and I get 25. Now if you look at that, if you go up to here, if you account for my whole units, you can see that I had 25 fifths. Or you look at this, right? Then you add the numerator to it. This is just one other way that you can do it. So if this is a confusing method for you right now, you can stick with the picture model, but this is another way that you can try this out. So again, the steps were take the denominator, multiply it by the whole number. So when I say whole number, I mean this number. Get your answer, and then add your numerator to that. So when I go 25 plus 4, I get 29. So I know I have 29 fifths. Yeah. So that's just another way that you can do it if you're feeling like this is a lot to draw. Let's try that method with the multiplication on the next problem, since it's actually a big one. So 6 and 7/8. So in this one, I'd have to draw 6 whole units and cut them into 8 pieces each, plus one more than 7/8. That's going to take me some time to do. You can totally do it that way. But you could also do the other mathematical way. So I'm going to go denominator, which is 8, times 6. So let's think about what that is 48. Then I take 48 plus the numerator, which is 7, and I get 55. And I need to make sure I put that over the top of the denominator for my answer. So a little bit different, right? A little bit cleaner than drawing out all the pictures, but you have to be really well organized if you're going to use this method. So again, the steps were denominator times the whole number, get your answer, then your answer plus the numerator, and then whatever answer you get for that, you put it on top of the denominator again. So 6 and 7/8 is the same as 55/8. Whew. Now, here's a great opportunity for you to practice both these methods. If you like the picture method better, go for that. And just remember to, whatever your denominator is, that's how many pieces your whole unit is cut into. So here are 4 for you to try it on. And find a way to communicate these with your teacher so that they can see how you're doing. But we've got 4 and 2/4, 3 and 1/5, 6 and 1/2, and 5 and 2/3. So give those a shot, turning them from mixed numbers into improper fractions. Use either that picture model, use the multiplication way, or use both and see if you can check your work that way. All right, thank you so much for learning with me today.